Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to this special video that I'm putting together today, and it's titled Winter Storm Threat. And no, you're not seeing double here. I just recently did a video for this past storm, almost a week ago now, for this past weekend storm that impacted large parts of the Mid-Atlantic, from the Carolinas with ice and snow all the way northward to southeast Virginia. And we had a really healthy snowfall for southeastern Virginia. I know Virginia Beach, I know recording outside in my own yard, I had about 6.2 inches. The Norfolk Airport had 6.2 inches. And now we're turning our attention to a new looming winter storm threat. And this would take place the 28th and 29th of January. That would be this Friday and this Saturday coming up. And it's hard to believe, but sometimes the atmosphere tends to sets itself up into a specific pattern, a repetitive cycle of sorts. And we're going to go ahead and take a look at this winter storm threat. Now, before I begin, I want to mention that, I'm not overhyping the situation in any way. I'm just showing you the possibilities and what today's model runs are showing for the storm. There will be a lot of change, and there's still low confidence in this forecast. So let's start off and compare the models, all right? We're going to look first at the GFS model for this Friday, the 28th of January, 2022. And notice the graphic on the left. The graphic on the left is showing a nice cold upper level trough. This is the GFS model, by the way, for Friday evening. This Friday evening, the 28th of January. A nice cold upper level trough, so we got plenty of cold air. We're looking at another cold week outside of Tuesday. Now, Tuesday, the 25th of January, we'll have a brief warm-up before things turn much colder again Wednesday, Thursday, into Friday. So we're going to have a cold upper trough, and then we have an area of low pressure off the east coast of Florida by Friday. This will be Friday evening at 7 p.m. Eastern time, okay? So low pressure is just forming off the coast. The graphic on the right shows the 2-meter temperature anomalies in degrees Celsius according to the GFS model. And note all the purple shading that is associated with the much colder Arctic air in association with this deep trough. Moving ahead now in the GFS model to Saturday, the 29th of January. And if you look at this particular graphic on the left, shows thickness values along with surface pressures. And this is for 1 a.m. on Saturday morning, the 29th of January. And at this point, we have a cold high position over eastern Canada. We have plenty of cold air working its way down the east coast. Very similar to the last storm, actually. And we have an area of low pressure, about 1,005 millibar low, that is situated off the coast of Georgia, off the southeast coast in general. And this upper level trough axis begins pivoting towards the east coast. So the core of the coldest air is now located from Ohio down through Kentucky, Tennessee, into Alabama, all the way to the Gulf Coast by late Friday night. Graphic on the right again shows those 2-meter temperature anomalies according to the GFS model in degrees Celsius, again showing the very cold air. These purple shadings here, very cold air over New England. Now, if we look here on the left, this forecast graphic would be for Saturday morning, the 29th of January at 7 a.m. Eastern Time. And notice this area of low pressure, the storm system is strengthening. It's now down to 1,002 millibars central pressure. And on the back side of this storm, northwestern shield, we're seeing snow from eastern North Carolina into southeast Virginia on off the coast. And there's some rain down into Florida, extending up the coast of Georgia and South Carolina. This trough is deepening. This storm is intensifying. And then graphic on the right, now we have I believe it looks like a 990 millibar low pressure system. So we have about a 12 millibar drop. This thing is starting to bomb itself out between Saturday morning and Saturday afternoon, right off the east coast. And you'll notice the blue shield here, that's snow from eastern North Carolina to southeast Virginia and just off the coast of New Jersey. So a very intense system. The winds are picking up from the north at this point. The main trough axis, the lowest thickness values coinciding with it, are now located from Pennsylvania down into central Virginia, right on down into the Carolinas. So we have this deep trough. We have upper level, higher heights across the western U.S. So we have a positive P&A. We have a deep trough off the East Coast. This is a great pattern for a storm system. Now let's turn our attention to the Canadian model. Let's compare. The Canadian model, this graphic on the left is Friday afternoon at about 1 p.m. Eastern Time. So this is Friday, 28 January. And there is a 1,004 millibar low pressure system located just off Myrtle Beach, South Carolina, and a 1039, a very strong Arctic high located over Iowa. And so we're getting that upper level trough again moving towards the East Coast. The very cold air is working its way into the coast towards the mid-Atlantic and New England. And this storm system is at 1,004 millibars. Has some rain up along southeast Virginia, all over coastal North Carolina, some snow on the backside, and even a little bit of ice. Graphic on the right. This is now, this would be Friday evening, 28 January. This would be 7 p.m. Eastern Time on the right. That 1038 millibar high is in a great position for another snowstorm along the East Coast, because the clockwise flow around this high is really funneling in northerly winds, keeping that cold air in place in the low levels of the atmosphere. Meanwhile, the storm system is now dropped 12 millibars and is just off, just to the east of the Outer Banks by Friday evening at 7 p.m. Eastern Time. Now, this is according to the Canadian model. Okay, so we have a rapidly intensifying storm, and it's also a much closer track compared to the GFS. You look at the GFS model, and this storm is much further offshore. And additionally, this storm system is GFS impacts are really Saturday, whereas the Canadian impacts really kick up Friday afternoon to late Friday night for the Canadian model. But this is just a great setup for another winter storm along the East Coast. That 1038 high, that very strong high over Des Moines, Iowa, and very cold air funneling down the East Coast. This is just a really good combination. Northerly winds on the backside of this intensifying cyclone. Look at these thicknesses crashing into Tennessee down to 510 decameters, very cold, all the way down to the northern Florida. You have the 540 decameter line. So we have a very well-defined, highly amplified upper-level trough over the eastern U.S. Moving on forward in time now, the graphic on the left on the Canadian showing, now this is at 1 a.m. on Saturday morning, so this would be really late Friday night, this Friday night. Generally, we have a shield of all snow, and this particular model, the Canadian, moves the storm parallel to the coast towards the north. Okay, so it's moving it more parallel to the coast to the north, and there's a lot of wintry precip from northeast North Carolina, southeast Virginia, up through Maryland, Delaware, New Jersey, Connecticut, Rhode Island. If this model is correct, it could have a major impact from North Carolina all the way up to Maine. Because by the time we get on the right here, this graphic, this is now Saturday morning, the 29th of January at 7 a.m. local time. This storm system is now at 957 millibars for low pressure. The center of the low pressure is at 957 millibars, and you still got some wraparound moisture still wrapping in. Now, this is really crazy because the 516 decameter thickness line is all the way down off the coast of South Carolina and all the way down to south central Georgia. I mean, this is just really, really cold air, folks. This model is showing much heavier snowfall outputs as well, the Canadian model, as compared to GFS, and I'll show you what those snowfall maps look like. The European model. Now let's take a look at the European model. This is for Friday, the 28th of January, 2022. Very similar situation here, synoptic setup, deep upper level trough, lower thickness values. You see the trough axis is positively tilted, and it's generally located from Tennessee down into like right around the northern Louisiana, East Texas area. Here's the disturbed weather, the area of low pressure or storm system forming in the west central Gulf of Mexico. Graphic on the right, we're moving ahead now to Friday. This would be Friday evening at 7 p.m. Eastern Time. Now you're starting to see the storm moving closer towards the Florida Peninsula, and you see this moisture, this overrunning moisture just offshore. And that moisture is tending to remain offshore with the European model. Let's keep going. Now the graphic on the left, this would be Saturday morning at 1 a.m. Eastern time, okay? So this is overnight Friday night and early Saturday morning. You see the storm system just off the coast of the Carolinas, and the moisture, this green and especially this orange and these blue shadings, that's the blue and the orange shadings are actually heavier precip amounts, as you can tell here by the legend. And you've got plenty of cold air here, okay? So the trough is deep, got cold air in place along the east coast, and you have this storm developing. Again, it's tapping into the energy between the warmer air over the Gulf Stream and that much colder air to the northwest. Graphic on the right, now we're moving ahead to Saturday morning at 7 a.m. Eastern time, showing a little bit of moisture just scraping North Carolina with potential wintry precip. All right, so a little wraparound moisture here, but the storm remains offshore. You noticing that? Now let's look at the different 500 millibar, 18,000 feet. These are your heights, your geopotential heights along with vorticity. And again, just as a reminder, the orange coloring is your greatest positive vorticity values. And you have a shortwave trough in this particular graphic here in the upper left. Now this is Friday morning. This would be at 7 a.m. Eastern time. This is Friday afternoon at 1 p.m. Eastern time, showing a positively tilted shortwave trough extending from Michigan down through Illinois, stretching all the way down through East Texas, northeastern Texas. By the time we move over here to the upper right, we're showing this would be Friday night at 7 p.m. Eastern time. That positively tilted trough is starting to work its way east. Bottom left here is the time. This time would be 1 a.m. on Saturday, 29 January. And a lot of energy associated with this particular trough, denoted by these darker orange shadings. Look at the legend here. These are positive vorticity values on the order of 35 to 40. Okay, and that would be, 35 to 40 vorticity values, positive vorticity. And then bottom right here shows Saturday morning at 7 a.m. Eastern time. Notice how the trough is located down further south. Okay, but you have a really good setup here. This is a really good setup for a major East Coast storm. Let's move ahead to the Canadian model. Same level, 500 millibars or 18,000 feet above the ground, and the vorticity values. So you notice with the Canadian model, this is a stronger system. Okay, and I can tell that by not only the coloring of the higher vorticity values, but I also can tell by the orientation of the trough, the shortwave. In this particular graphic, this is Friday afternoon at, this would be 1 p.m. Eastern time, up here in the upper left, Canadian model. I'm already seeing a neutrally tilted shortwave trough. Let's go back to the GFS. Same time period. You notice I am more of a positive tilt trough, and that positive tilt extends from the northeast to the southwest. Now, this particular model shows a neutrally north to south oriented trough axis. We get over here on the right, upper right hand side. This would be for Friday evening at 7 p.m. Eastern time, and now this trough is trying to take on a negative tilt. So here's the importance about the tilts. I probably should have thrown that in this presentation tonight. The difference between a positive shortwave trough tilt, a neutral shortwave trough tilt, and a negative shortwave trough tilt. These are significant, okay? So whenever you get more of a negative tilt, that would be an orientation of the trough axis from the northwest to the southeast. That tends to indicate a stronger system, a much more intense system when it comes negatively tilted. Another major feature of a negatively tilted trough that's very important is it tends to drag or pull the surface low, the storm system, closer to the coast for the track. Okay, so if this particular Canadian model is correct in its depiction of this axis of the shortwave trough, if it becomes starts off neutral here on Friday afternoon, then starts to become negatively tilted by Friday evening, and then if you look at this graphic at the bottom left, we've got a much stronger system in general. This is 1 a.m. on Saturday morning, 29 January. A lot of energy. See the red and the maroon shadings? Lots of energy with this trough. Got a nice little ridge built up here in the western U.S. and the western Canada, and this trough is just digging. Okay. Now, if you look at the graphic here on the bottom right, this is for Saturday morning at 7 a.m. Eastern Time. Look how much further north. Let's compare. GFS remains pretty much further south, and then it develops a storm off the coast and then pushes it out to sea. Whereas the Canadians got this closed upper level low at 500 millibars or 18,000 feet situated right off of Long Island. Okay. So if you believe the Canadian model and if it verifies, this particular storm is going to be very significant, number one, very strong, and could impact a larger area to the north as well, all the way up towards New England. All right. Now let's look at the European 500 millibar level, 18,000 feet above the ground with the vorticity. Pay attention to the orange shading. That's the highest positive vorticity values, generally. And associated with this, I'm looking at the trough axis. Upper left here is for Friday afternoon, 28 January, early afternoon, showing a positively tilted trough. The energy associated with this short wave is located mainly over North Mississippi down through Louisiana, East Texas. Graphic upper right shows Friday afternoon, the 28th of January. I'm sorry, Friday evening. This would be 7 p.m. local time Friday evening on the upper right. Look at this ridge building. This upper level ridge is building from the southwestern U.S. up to western Canada with a deepening trough downstream over the eastern U.S. off the east coast. And look at your shortwave trough here, this piece of energy from North Georgia down through Alabama, across parts of South Mississippi and eastern Louisiana. The bottom center here, this graphic represents the period around, this would be Saturday morning at 1 a.m. local time, Eastern time, showing that shortwave trough axis still remaining positively tilted, okay? So the European, although it shows a strengthening storm, it doesn't have it as strong as, let's say, the Canadian, okay? So mostly a positively tilted trough stretching from southern Jersey down through southeast Virginia, northeast North Carolina down through the Gulf Coast. So there's quite a bit of model uncertainty regarding the upper level features with this particular storm. And these are very important features, and I'll show you here in a moment why positive vorticity advection, why these increasing levels of vorticity really matter as far as the storm goes. So we're sitting 6 days out from this event, okay? So there's going to be a lot of changes. There's going to be a lot of differences with these models. Not only with the surface storm track, European keeping it offshore, Canadian much closer to the coast because of a stronger shortwave trough at 18,000 feet. And then the GFS is very similar in track to the European, actually. It does have intensifying. In all three cases, this is going to be an intensifying storm system. GFS, Canadian, European, doesn't matter. It's going to be a stronger system as it moves over the western Atlantic at some point. All right, so now let's take a look at the 300 millibar forecast. This graphic on the left shows European 300 millibar forecast. This is for Friday evening, the 28th of January. And generally, I wanted to point out a real interesting feature here on this particular 300 millibar level. Now, the 300 millibar level is up at 30,000 feet above the ground, and this is where our jet stream resides, at 30,000 feet above the ground. What we have going on is this nice upper level ridge extending into, this would be British Columbia and Alberta in Canada, the provinces of British Columbia and Alberta. So we got a nice, huge upper level ridge. This is just ideal, positive PNA pattern, and we have this energy diving into the base of this long wave trough. Get long wave troughs at 300 millibars. And out ahead of the trough axis, this long wave trough axis, you have a lot of jet stream energy. What do I mean by jet stream energy? I'm talking about wind energy. And so you see this brown shading, this lighter brown coloring here across northeastern North Carolina, southeast Virginia, across the southern portions of Delaware and out over the western Atlantic. This is associated with a 145 to 152 knot jet streak. We call them jet streaks. These jet streaks are energetic accelerations of wind within the main jet core or jet axis. And they are very important for our weather here on the Earth's surface, and you wouldn't think so. You know, you're just saying, okay, it's raining or it's snowing on the ground, but what's happening up at 30,000 feet at that 300 millibar level with the jet stream really does matter. You look at the upper right-hand graphic here. This shows a sample of a jet streak. And if I were to take let me see if I can get it. I'm going to try to play with this for a minute. Let me see if I can actually do a pen or something. Let's see. If I were to draw basically divide this jet streak into 4 quadrants, okay? Just like this. You notice how I'm basically making these red marks kind of like in almost like a plus sign. I'm dividing this jet streak up into 4 quadrants, all right? This particular quadrant here and this particular quadrant here are associated with rising air motion in the atmosphere, okay? And that is shown here on this diagram in the upper right, where on the left front quadrant and the right rear quadrant, I usually have what's known as upper level divergence, or the removal of mass aloft, which allows air to rise more readily vertically in the atmosphere. So if I'm located at this point in relation to this jet streak, the left front quadrant, or in this particular area, so left front and right rear, the right rear quadrant, that's where I'm going to get my greatest lifting. When I have air rising in the atmosphere, it's going to cool, it's going to condense, it's going to produce heavier precipitation. So this potential East Coast storm this weekend, if we look three-dimensionally, it's got a lot going for it, okay? It's got jet stream energy, it's got a lot of shortwave vorticity, shortwave trough, very deeply amplified shortwave trough, as well as a lot of vorticity associated out ahead of that trough. But I wanted to really make a point about this chart. Why am I showing something that is 30,000 feet above our heads with the jet stream? Because this is an added piece of energy in the atmosphere up there. And you're located in this location in Southeast Virginia or over North Carolina, these are your 2 favorable areas for rising air in relation to this jet streak. All right? Just wanted to point that out. Now let me go back to my regular tool here. Whoops, wrong one. Whoops, I went the wrong way. Sorry. All right, so we go back to my regular tool here. Okay, so here's our jet streak. So we have the energy. Here's our diagram of the jet streak and why it's important based on these quadrants, left front, right rear, left front, right rear, rising air motion. Okay, now look at the bottom right here. This is showing, we go back here, let's see here real quick. So we talk about the vorticity and these short waves, these shorter amplitude waves of the upper atmosphere at 18,000 feet or 500 millibars. Okay, we generally have a trough axis, and out ahead of that trough axis, the air rises. So if I use this, let's just say I use this graphic here. Let me do this again. All right, so in this particular graphic, the shortwave trough is right here. And the positive vorticity advection is going to occur downstream or to the east of this shortwave trough axis. Generally in this location, the air is going to be rising. Same thing here. Now we're getting more of a negative tilt here, but we're still getting upward vertical motion, rising air ahead of the shortwave trough axis associated with positive vorticity advection. All right, now let's move ahead. How does that relate? How does that relate to the atmosphere? Let's take a look. Okay, so the bottom right image here shows a sample shortwave trough. Right, so the trough axis would be right in here. Okay, generally, this area positive vorticity advection, the PVA, is ahead of the shortwave trough axis at 500 millibars or 18,000 feet, and that tends that upper level divergence or removal of mass. See this upper level divergence? That tends to remove mass aloft and allow for rising air motion. See this red arrow pointing up? That's air rising from the ground up into the upper atmosphere, and as it rises again, it cools, it condenses, it produces precipitation. And whenever you're basically to the east of that trough axis, and you have the PVA, you get this surface area of low pressure to kick off or basically develop. And if you get enough vorticity, strong enough vorticity, if that vorticity is, let's say, higher positive values, that will strengthen, that acts to help to remove this upper level divergence, remove this mass much more faster than what's coming in from below, and you get a lowering surface pressure, intensifying storm system. And that's exactly what we're looking at this weekend potentially. We're going to have this nice ball of energy right here moving towards the east coast, and out ahead of it, you're going to get a lot of rising air motion, some accelerated lifting. Okay, so notice behind that shortwave trough axis, though, we have something known as negative vorticity advection, NVA, and see the blue arrow pointed down? That's associated with surface high pressure, and once the storm moves away, this high pressure at the surface builds in, and you get sinking air motion in the atmosphere. Okay, this is called negative vorticity advection. This is where your vorticity values actually decrease over time. So this is all connected. Whether we talk about the jet stream at 30,000 feet, 300 millibars, whether we talk about shortwave troughs at 500 millibars or 18,000 feet, the air, to get a really good intense storm, you need rising air motion all the way up through 300 millibar level, all the way up from the surface, all the way up to 30,000 feet above our heads. And that is on the table for this weekend. This storm is looking rather intense. No matter what the model we look at, it's a very intense storm potential. Okay. Now, let's move ahead and look at the snowfall maps. All right, this is based off the 12Z 23 January, Sunday 23 January 2022 model output. But generally, the GFS, this blue shading, is indicating general 1 to 3 inch snow from northeastern North Carolina up through southeast Virginia, on up to Maryland, up to Delaware and New Jersey. And the higher amounts are associated over here. They're back towards the mountainous areas of West Virginia. Canadian model snowfall forecast off 12Z, 23 January 2022 model output. Now this is no surprise because we looked at it and we saw the Canadian model was showing a stronger storm system, right? Much more intense storm system and a closer track to the East Coast. So therefore, this model is showing 7 to 8 inches across southeast Virginia, 3 to 5 inches across northeast North Carolina. And then as the storm goes up the coast and continues strengthening, now we're talking about a 13-inch, 14-inch swath of snow from southern Jersey up the Jersey coast. Okay? Now, what about the European model? The European model, since it keeps a more suppressed storm track path and well offshore, it only shows about 1 inch to 2 inches of snow confined to northeast North Carolina and just a half an inch over southeastern Virginia. And notice the Canadian was showing much more snow, right? See this? 5 to 10 inch swath up to southern Jersey and then even higher from there. Look at the European. Not really much. All based on storm track. Okay? So here are my final thoughts on today's special video. And I really want to emphasize point one. At this point, we're still 5 to 6 days out from this potential storm. The potential, see that? The potential, in quotes, exists for a significant East Coast winter storm on Friday, 28 January and Saturday, 29 January 2022. Now, this makes a lot of sense. The pattern's favorable, deep trough, okay? We have this nice deep trough in place across the eastern U.S., and we could be looking at a transitioning pattern from very cold to mild. And usually at the beginning and ending of these kind of pattern transitions in the atmosphere, you tend to get a much stronger storm system. Now, right now, there's lower confidence at this point in the forecast as we are still 5 to 6 days out. The models will continue to fluctuate regarding storm track and intensity. It's just going to happen. It's just interesting. These models started showing this feature about 2 days ago. On Friday, the 21st of January, started kind of hinting at things developing off the East Coast like this. But we all know the finer details. We're well out in time. So that's going to change. Again, the pattern is very favorable for the development of a storm system as a cold upper trough will reside over the eastern U.S. and will have plenty of energy in the mid-levels of the atmosphere at that 500 millibar level associated with the subtropical jet stream. And that would be this feature down here. That would be this feature, okay? All models are showing this nice little positive vorticity lobe, okay? Heading towards the East Coast. GFS is further south. Look where the lobe is, the greatest vorticity on the GFS model, further south. What about the Canadian? It's further north, okay? A little bit further north. Look at the European. It also is very similar to the GFS with that positive vorticity lobe further south. So in the GFS, in the European, you have more suppressed storm track further south and offshore, and therefore your snow totals are much less. GFS on the left, European, as compared to the Canadian. All right, plenty of cold air is going to exist over the eastern U.S. this week in general. Between 24 and 28 January, we're going to have a lot of cold air in place. We have a reinforcing shot of cold Arctic air moving in fact, Wednesday the 26th of January. European model is keeping the storm offshore with little or no impact. GFS model brushes the mid-Atlantic coast. And then the Canadian model is the most bullish of all models, all the deterministic models, with a closer track to the coast and much more significant impacts. The ensemble models are also showing a storm of some sort just offshore. So whether it's the GFS ensemble forecasting system, the GEFS, or the European ensemble system, the EPS, they're all showing some type of storm with various storm positions, right, over the Western Atlantic. Multiple possibilities do include no impacts at all with the storm. With the storm just moving well offshore, it'll just be cold and dry along the eastern seaboard. So that is a possibility. Additionally, we could see a storm that's much stronger than the last one. We will see that. I'm very confident we'll see a much stronger storm system off the East Coast than the last one we just had this past weekend, 21 and 22 January. And if that storm track is closer to the coast, we could have much heavier precipitation and much greater impacts is what I'm getting at. So, no impacts at all with the storm well suppressed and offshore. A storm much stronger, closer to the coast, heavier precip possible, much more significant impacts for the East Coast cities. That is also. So there's two possibilities right now. And I always say this, stay tuned for the latest updates. There is a lot of uncertainty at this point. All we can do is watch the trends. And again, this model or this video is by no way any type of hype video. This is just stating the facts. I just like to throw out the different models, compare it. You can see the differences, the different features that favor a major storm system developing and moving up the East Coast between next Friday or this Friday coming up, the 28th of January, and Sunday, that'd be the 30th of January. Okay, so that's all I got for right now, everybody. Again, thank you for subscribing to the channel. I hope you get really good knowledge and education out of these videos. Not that I'm just showing you charts. I'm trying to explain those charts to make it easier for you to understand and comprehend. But overall, the signal is there. Definitely going to have to keep an eye on this one, folks, to see how things transpire over the next 3 to 4 days. The other things that we'll have to keep an eye on is the North Atlantic. I didn't mention it, but the northern and northwestern Atlantic. Will we get an upper level high pressure to build over the top of this thing, which will be associated with a negative North Atlantic oscillation, NAO, and that potentially could also help keep the storm closer, more pinned to the coast as it moves northward. So there's a lot to look at here. These systems are never easy to forecast. But just putting my ideas out for right now here as of Sunday, the 23rd of January, 2022. All right, that wraps things up today. I hope everybody has a awesome Sunday evening. Until next video, take care and God bless.